So you just watched a video from the Khan website about how to graph a sine function, and so we're just going to review a couple things and then we're going to go ahead and continue to graph a few more examples. So remember the sine function, we're going to use this equation here, a times b theta for the sine and y equals a times cosine of b theta. And this a and this b are going to be pretty significant in helping me figure out the amplitude and the period. So here, then I believe Khan talked about what letter represents the amplitude, and that would be your letter in front of the sine or the cosine function was called your coefficient, which would be letter A. And what does the amplitude mean? The amplitude is the maximum height, or the max height, just abbreviate, the graph reaches. So here, if we look at our cosine graph, we've lost track of it. Let's say this is a 2, it oscillates, this is oscillating between 2 and, call this -2, so the amplitude here would be 2, and it would be y equals 2 sine of theta. So the amplitude is that number in front of, is a coefficient in front of the sine function. So what letter, let's continue on, what letter is used to calculate the period? The B is used, but how is it used? If you want to find the period in radians, you would take 2 pi divided by the absolute value of your B. Remember, absolute value is a measure of distance, so that will always be positive. And this will give you the number of radians. If you want to find your period in regards to degrees, then we take 360 degrees over the absolute value of B, and that will give you your degrees, your period in degrees. Either one is fine, just depends. We'll typically be using radians. Okay? So what does the period mean? It's the length the graph takes to repeat itself. Okay, so it's also how fast does it oscillate. So if we look, could oscillate a little bit slower, or maybe it oscillates really fast. Okay, and you'll learn what the value of B is given if it really takes a long time for it to repeat itself or if it repeats itself pretty quickly. And we'll look into examples like that in just a second. So, and the last thing, how do we create a table? In just a minute, you're going to have to create your own table given theta, sine of theta. Well, really, how do you know what increments to go up by in theta? Because if we think back to algebra class, we would take our typical table of values, -2, -1, 0, 1, 2, and that's how we would make our table of values for a linear equation. Well, how do you find a typical table of values for a sine or a cosine function? Well, we want to focus on I'm probably butcher the name, the quadrantal angles. We're going to focus on the quadrantal angles, and those angles are really the angles. It's an angle with the terminal side on the x and on the y-axis, or on the x or the y-axis. So there are all these points, and we know these points are 1, 0. Can you see that? Yep. 1, 0, 0, 1, -1, 0, and 0, -1 down here. And so if we think in radians, well, this is 0 radians. Here we have pi over 2 radians. We come over here, we have pi radians. Come down here, can you still see? 3 pi over 2 radians. And we make a full circle, that will give me 2 pi radians. And if I keep going, if I come back up again, so I would be 450 degrees, that would be 5 pi over 2 radians. Keep going over here, 3 pi. Come around again, the next one would be 7 pi over 2, and we'd be back up at 4 pi. So I think you get that idea. If we look at degrees, let's do degrees in green. Degrees, 0 degrees. And I come over, I know this is 90 degrees. Over here, straight line gives me 180 degrees. Come down here, 270 degrees. Right here, I'm down. These are all representing that, 270 degrees. Over here, if I make a full rotation, that would be 360 degrees. Let's go for another rotation. So a coterminal angle with 90 degrees would be 450 degrees. Keep going all the way around. 180, a coterminal angle with 180 would be 540. Go again after 270 would be 630 degrees. And back up to 720 degrees. Okay, that just gives us an idea of what I'm talking about. So to know, the question though is, how do I know what increments to go up by in my table? What we take is, you're going to take your period and divide that by 4. So whether you figured out your period in radians, divide that by 4, or if you figured out your period in degrees, you're still going to divide that by 4, and those are the increments you're going to go up by. Okay, so let's actually take a look at that for our cosine function, which did not get graphed yet. So if you turn the page, you have your cosine function, and we're going to actually apply this. So if we think about the generic function y equals a cosine of b theta, what is the value of your a? What's the coefficient in front of cosine? Well, if there is no number, you assume it's the number 1 in front, because 1 times anything doesn't change the value. So a here is equal to 1. So when I go ahead to try and find my amplitude of just y equals cosine of x is going to be 1. That means that, let's say I go up a quarter each of these, so I'll float between 1 and negative 1 on my graph. So this is going to oscillate between 1 and negative 1, back and forth. And the period, well, if I do it in radians, 2 pi divided by the b. Well, the b in this case, there is no number in front of theta, so again, you assume it's 1. 2 pi, anything divided by 1 is just that number, so the period here will still be 2 pi. So let's actually think about then, well, what increments am I going to go up by? Well, remember we said we would take, to find the increments we go up by, we take 2 pi divided by 4. So 2 pi divided by 4 reduces to pi over 2. And we know pi over 2 is 90 degrees. So I'm going to be going up every 90 degrees in my table. So if I take 0 radians, or I'll even write the degrees on top, that would be 0 degrees. The cosine at 0 degrees, we have to think about our unit circle. The cosine at 0 degrees, I can do a thinking box off to the side, thinking over here. Cosine, remember, is your x value. So the cosine at 0 radians or 0 degrees is 1. Ignore this approximate value. We're not going to use that right now. Okay, so then if I go up pi over 2 radians, the next one will be pi over 2. I'll just go ahead and fill these in. If I go another pi over 2 plus pi over 2 is 2 pi over 2, which is just pi, or 180. If I add another pi over 2 to that, that would be 3 pi over 2, which if we think about that, that's 270 degrees. If I add another pi over 2, that is going to bring me right back to a full rotation, which is my period when the graph repeats itself at 2 pi. So we'll just fill in the degrees in case you're a degrees person and it helps you to see it in degrees. Pi over 2 is right here at 90 degrees. Pi, remember, is a straight line, 180 degrees. 3 pi over 2, 270 degrees. And 2 pi is a full rotation at 360 degrees. Alright, so if I have to graph this, here's my theta axis, and I'm graphing 0, 1. At pi over 2, we're going to skip 1. We'll do pi over 2, skip, then we'll have pi, skip, 3 pi over 2, skip, and 2 pi. Okay, so hopefully you see those. So at 0, we are at 1. At pi over 2, we didn't fill in the rest of our table. Pi over 2, what is the cosine value right here at pi over 2? The cosine is 0. What is the cosine at 180 degrees or at pi? The cosine is -1. At 3 pi over 2, we're back to 0. Again, remember the cosine is your x value at these points, the x value at these points. And the last one, back to 2 pi for rotation, will be back at 1. So pi over 2 is at 0, pi was at -1, 3 pi over 2 back to 0, and 2 pi is up to 1. So what does this look like? It's oscillating between 1 and -1. I could keep going on forever. We could keep oscillating, so I put an arrow on, meaning it's going on in that direction forever. And it also can oscillate this way. So we'll say -pi over 2 and -pi, so -90, -180. -pi over 2 would be at 0, and then -pi would be at -1, and I could keep oscillating this way, goes on forever. So here we have now graphed our cosine function, okay? And so we're going to end this will be part 1 of graphing, and in just a minute we will also graph a couple more examples just to help you out and to get started.